Okay, good evening. Tonight we're going to be talking about data structures, and specifically some of the more complex data structures that Ruby has for us. So some of these I'm going to assume that you might have seen already. Some of these you probably haven't, depending on how far we get through talking this evening. As we're going through these things tonight, if you have any questions, any comments, anything you want to dive deeper into, please just let me know, throw it into the chat window, or just unmute yourself and ask your question, or shoot it that way. Either way works for me. I always like to let people know that what you're seeing, what I'm sharing, is my second monitor, and my chat's on the other monitor. And it isn't far, but sometimes I just get zoned into what we're doing that I miss the chat window. So if you put something in there and I don't respond right away or act like I don't see it, I might not have just glanced at it. So I promise I'll get to it if you do it via chat. And I'm trying to be better at that. But tonight we're going to talk about data structures. And I want to take a step back. And before talking about data structures, I'm going to talk about kind of what a data structure is and what makes up a data structure. And it's going to be a little bit probably abstract and more technical and lower level than we ever really need to know, but I think, or that we'd ever interact with. Maybe not need to know, but it's good to know that there's more going on underneath, and it'll help us with our understanding of the data structures that Ruby provides for us. So, excuse me. Before we get to data structure specifically, we need to know that in computer science, and coding is computer science in the end, it's interacting with computers. And there is something called an abstract data type. And this is a mathematical model for data types. And it's where a data type is defined by its behavior from the point of view of a user of the data. And specifically in terms of possible values, possible operations on data of this type, and the behavior of these operations. So I'm not expecting anybody to really grasp that, but just know that there is this thing called an abstract data type. And some common abstract data types include containers, lists, sets, multi-sets, maps, multi-maps, graphs, stacks, queues, priority queues, double-ended priority queues, and that's a good overview of just some of the more common ones. So we'll see how this connects in a few minutes, but data structures are a particular way of organizing and storing data in a computer so that it can be accessed and modified efficiently. So if we think about that, we start maybe getting some ideas of what data structures represent. And more precisely, a data structure is a collection of data values and the relationships among them and the functions or operations that can be applied to the data. So now I think it's starting to maybe things and might be popping into your mind. And data structures can implement one or more particular abstract data types. So a data structure is implementing abstract data types, and that's why I started with what an abstract data type is. And data structures are implementing implementing one or more particular abstract data types which specify the operations that can be performed on a data structure and the computational complexity of those operations. So that complexity part is going to come in, and we're going to look at that a little bit. So if data structures are implementing one or more particular data types, why would we want different implementations of the same data types? So the answer is complexity. And complexity is measured by something, and I promise we're going to get to some Ruby code. It's probably going to look really familiar in just a minute. But I wanted to give a good base of some things that you're probably going to hear out there in the wild, so to speak, if you go to meetups, if you're talking to people who've been programming, if people programming in lower level languages or been working with code for a long time, a lot of these things are brought up. You might see people discussing things, and having a good base, even if it's just a short overview, I think is going to be helpful overall. So complexity is measured in something called Big O notation. And this is bigocheatsheet.com. It's a great resource. Whenever I see people talking about Big O, especially online, this is typically referred to. It's written by an engineer, senior engineer from Workday, if I remember correctly. I just went That's his little Twitter link, and that's where I saw that. But what Big O does is it's a mathematical notation that describes the limiting behavior of a function when the argument tends toward a particular value or infinity. So really what we're saying is in computer science, Big O notation, it's just a way of expressing something, but it's used to classify algorithms according to how their running time or space requirements grow as the input size grows. So, you know, if something is more complex, let's say if you're doing a function or iterating over an array versus a stack versus a queue, how that iteration works, it might take 1 pass, it might take 10 passes. That's a different level of complexity. And Big O notation characterizes functions according to their growth rates. So different functions with the same growth rate may be represented using the same O notation. So it's a Big O notation is all about how complex things get as the data structure grows. So we'll see some common data structures here. So arrays, that's something that we know about. Hash tables, we don't have hash tables per se, we have hashes in Ruby, and some other things here. And then array sorting algorithms. So these are all different ways that you can do sorting of arrays. And then there's this little cheat sheet. And this is good to know just because you'll hear it talked about Big O, how complex something is. It's the efficiency of a function that we write. So now let's step into some Ruby in the REPL over here. And the first data structure that I want to talk about is an array. So an array is a collection or a list being one of those abstract data types. And that's the data structure. An array is a data structure. So if you're thinking, you know, data structures were some really complex thing, no, an array is a data structure in Ruby. So we'll look at arrays just a touch, then we'll dive into some other things and keep it going from there. But I think arrays are a good place to start. And if you're wondering what the data structures in Ruby are, to my knowledge, from my research and understanding, they are arrays, and I guess I can type them here for us if I'm in my browser editor. Okay, there's 6 that I know of. We're not going to look at all of them. There's one more space there. We have arrays, the hash, set, and sorted set, matrix, vector, and range. Some of these have very specific use cases, but these are the data structures in Ruby that I uncovered in looking for data structures. So we can try and see if we can look at examples of 4 of these tonight. Arrays, hashes, sets, and ranges, if I remember correctly, if I have in my notes, and just get a little bit more comfortable with them. So arrays. Arrays are an implementation of a collection or list. So it's used to store a list of values, and it can be integers or strings or whatever we have. So if we had a bunch of integers, this is tiny. That's better. Trying something different using the REPL. If it doesn't work out, I'll pop over my code editor. But I want to play around in here because this is a fun tool if you haven't used it yet. REPL.it. And yeah, you can just throw your code in here and play with it. So if we wanted to keep a list of integers in an array, here we have it. And let's keep these as kind of like headings. We'll keep track of our code this way. And then I could turn it into some notes. So this would be a really simple array in our case. And that would be how we create our array. And then if we wanted to get information out of an array, arrays have the concept of the index. So arrays in Ruby are zero indexed, just like some other languages, but not everything is zero indexed. I definitely know that for sure, and that throws off, I think, lots of people when you run into that off case where they are not zero indexed. So in some languages, this is going to be indexed as 1, 2, 3, 4, 5, 6. But if we wanted to access one of these integers, we'd call it with its index. So right now, this is index 0, this is index 1, 2, 3, and 4. Oh, I probably wanted that to be a 5 to just look better. So if we wanted to get that first element, that first value, we would call it by its index value, which is 0, and that would return the 1. If we did 1, if we did 4, we would see the associated values. And we're just getting the last one. Here, let's put this. So it will print to our terminal 1, 2, 5. So it prints the 0 index, then the first index, then 2, 3, 4, the fourth index. So we get 1, 2, 5 in our terminal. Now, just like we can store integers, we can store strings. We could have a list of names. And in addition, arrays don't have to live on one line. So we can have an array of names just like this. Be Seth, it's separated by the comma, just the same as the integers. I could say David and Denise. Sorry about that. My internet just went crazy. Okay. Yeah, sorry. Internet issue. That hasn't happened before. Okay. Let me get the chat window back open. So I'm going through all these things with arrays because we want to be able to compare it with other data structures as we keep going. So I want to be able for us to look at what we're doing with arrays, which we probably are familiar with, and then look at other structures and see the differences. So if we wanted to add to an array, there's two different ways. We could say, since we have our names here, we could do dot push and add a name. or we could use the shovel. And I fought against the shovel because I had learned JavaScript first and I liked push, but the shovel is pretty neat and it's so simple and so straightforward. It's really, and let's put names. It really is a nice way of doing it. If we run our code, we should see this names array with these two added to it. Is it running? Oh, there we go. Okay. It might have been having some issues because it got disconnected for a second with my computer, but there we go. So we see the full array with all the names being output. So something that is interesting, and you probably don't know, is that this shovel is a method. So it's actually the equivalent of doing, and it's just nicer to not do it this way, visually nicer, this. So we're calling that shovel method on names and adding that name. If we run this, we should see the same thing come out the other side. And then we'll move on to hashes. Oh, this is slow. Okay, REPL. I'm going to copy this. I hope it's just because of the internet blip that you're acting slow, because I've never seen it do this. If not, I'll just run this locally. But coming up, we're going to look at hashes. Let me grab this, and I'll bring it down. We'll keep going. So hashes are going to be our key value data structure. So they're a dictionary collection. There we go. And we'll keep a copy of that, showing both. There we go. And then, let's see if, there. So arrays are indexed with integer numbers, but if we don't want to use integer numbers as indexes, the hash is going to allow us to use a, what you call it, a value, a key. And there's two different ways to create hashes. There is a literal way and a constructor way. Throw some lines down here. Perfect. So, and the same is true for arrays, which I should have highlighted. There we go. It's also possible, like with arrays, to create a hash with a starting value. So we could also initialize this with something like this. and say red this is the code for that one, and blue. And that will return our hash of those two. So if we try and access a hash with no value, it will return nil. So if we said, let's say h equals hash new, and then we try and access. So accessing, just like an array, we're going to use the brackets, but instead of an index, we'll be calling a key. So this is array, it returns nil. So we can set up a default by passing an argument. We said hash new 0. And when we call it, we'll get 0 now. So this doesn't create the key when we try and access it. So if we call, I guess, h, we still get empty. And yes, sorry, checking notes on something. And yeah, so we still get empty. Now, if we wanted to, let's grab this, just run this. Cool, so now we have our colors here. If we want to remove a key pair from a hash, we can delete it. And it might be tempting to set the value to nil. However, the key will still be part of the hash. So that's something that we have to remember is the keys and values here in our hashes. So if we did something like colors, and we see we access the values through, oh, that got converted. I didn't know that would happen. Huh. The hex got converted to integers. So if we access it like that, we could do something, or be tempted to do something where we set it equal to nil. However, our colors hash is still going to have two things in it. If we look at colors, we see red, nil, and blue. So the proper way to get rid of values is to delete, because we want to get rid of both the key and the value pair. And that actually happens with parentheses because we're calling the method. And as that returns nil, it's because it's gotten rid of it, and there our colors is now just blue. Now, something that you've probably seen is two different types of notation with hashes. So you've seen, if you've watched any videos with Avi, you've seen he loves this hash rocket. And that's because the hash rocket was around way back in the day. I think it was, I saw it in my reading. I think the hash rocket was required and there was no other way of doing hashes except with the hash rocket, as this is affectionately called, until Ruby 1.9 when that changed. And after that, there's another option. So a popular pattern with hashes in the hash data structure is to use symbols as the hash keys. Now, I've had people ask me in the past, why symbols? And it's because, and I've learned this recently, symbols, let's call this something else, are like strings. They're descriptive like strings. However, they're fast like integers, so their usage is a lot faster. So they're not evaluated like strings, and that makes them a lot lot faster because things that are typically in hashes become larger. They're supposed to be a dictionary. They're supposed to be a lookup, something that we want to use often. And these symbols are just faster because they're going to be evaluated like symbols from what I understand. However, like I was saying, starting with Ruby 1.9, if the key is a symbol, we don't have to use the hash rocket. So we could build this same exact hash. And we can throw the colon on the right side and build our hash. And pig. Not pig, pig. So these two hashes are equal. They're doing the same, being built the same exact way. It's just where the colon is put and not needing a hash rocket in this new notation. One thing to keep in mind though is that any other key type that isn't a symbol will still have to use the hash rocket. So it could be confusing if you have some that you want to be strings, some that you want to be symbols, and such. So you can't do this all the time, but only when you're using symbols. And if you've come from another language, this probably looks similar to you from either JavaScript, like JSON objects look like this, or even Python looks like this with its lists, I think. I don't know much Python, but I know it looks somewhat like this. Okay, so now on to, we've looked at hashes and arrays, things that we might have seen depending on where we're at in the program. Now let's look at a different data structure. I'm gonna grab this set, bring it down here. So the set. And all these things you can find in RubyDoc as well, or you should be able to. Let's go to 2.3.1. Go to classes. Oh, they're in here somewhere. I know array is, hash is. Where is it? It's in standard library. I'll find it. We won't get hung up on where it is in documentation because I know it's there. Quick Google and we can find it. So if you're going to work with a collection, and this is another collection, a set is another collection. So if you're going to need a collection where the order does not matter and the elements are guaranteed to be unique, then we probably want to work with a set. And these data structures are what's it called? Yes, sorry, I just saw that. We would access these. We can do that. Let's get rid of one of these and run this so it's available here. Yes, we would access these with the symbol. So the symbol is a type of value, type of element in Ruby. So here, if we said cow, we get the cow. Whereas if we tried to use a cow, that's a string. So that's going to be a different type of element. And Ruby, let's see if I remember some of my Ruby. I think if we call class on this, there, symbol versus if we call the class of that, we get string. So those are considered two different things in Ruby. Good question. Wish I would just stay lit up. Oh well. You're welcome. Yeah. I was thinking type of for a second, but I was like, no, that's JavaScript. You do type of, and it'll tell you. So something that's different about sets when you use them is that you must add a require statement to make and use sets. So they're included in the Ruby library and the base Ruby library, but you have to require them. So as long as you have Ruby installed, this will work. You don't have to have any gems or anything. This isn't doing that. This is just saying you want this extra feature of Ruby to use this. And in addition, unlike arrays and hashes, and this we're going to start getting into some differences, set does not have any kind of literal syntax. So we could pass an array to set, however, we'd still have to use our constructor. So let's say we want to build a new set. I have to run it here first. Oh, not set, set.new. And we could give it an array. Say 1, 2, 3. Let's run that. And we see we have a set. That should be available here. Should have set available now because of that require, hopefully. We'll see what happens. And then if we did something like an array 1, 2, 3, 4, there is a function to set. And that'll create a set. So those are the two ways to start and create a set. So some differences from arrays is, let's throw this over here. I want to keep a little log of our things because we'll probably delete as we go and clear. Now, if we want to add to a set, so we have this set that is equal to, or S is equal to set, set, or it should be, it was. All right, terminal, it is. All right, let's see how this works out for us. This equals set dot new. Say require set. Okay, so let's play around in this terminal because this one is not doing anything for us. Okay, so we have this set for S. And if we want to add to this set, we have two ways of doing that. And we can use our shuffle, just like so. Well, we have 1, 2, 3, so 4 on there. So we have 1, 2, 3, 4. Or we can use we don't have a push. That's the difference here. We have an add. So let's say 5. And that is going to tack on for us. Now, let's do an add of, let's say 3. We see it doesn't duplicate. So that's what we were talking about at the beginning of talking about sets. When we want to have a unique set, this is not going to allow for duplicates. So it's going to have a very specific use case when we want that type of action. It's also going to make sure that it stays unduplicated. It is going to share some methods that are known from more popular data structures like arrays. So include is one of them. So if we did s.include question mark, we could pass a number to that, say 4, and get a Boolean back, true or false. So yeah, that's a cool thing. Something that you might not have seen and might be confusing you, so I should point out, is that parentheses are pretty much optional in Ruby. They can be included or they can't. If you've seen that I did include there, you might have seen include like this. You can do set new. Let's make this R like so, and it'll still work. So try not to get caught up on the syntax. I do know that I'm jumping around kind of back and forth and doing it differently. So if that's confusing you, they are optional for the most part. I can't think of any time that I've run into that you have to explicitly have them as long as your spacing is right. So arrays can perform Boolean operations, sets can too. If we did, so Boolean operations meaning ands or ors types of things. So let's say, let's do set1 equals, I'm going to use the toSet method here. And then s2 equals, let's say 2, 3, 4, toSet. And if we did something like s1 and s2, this should tell us where they have, yep, things that are in both of them. Or if we do s1 or s2, it's going to tell us, kind of mash them together for us and show us what's in both without any duplicates. Something that it can do, unlike arrays, which can be useful at times, is exclusive OR. So if we were to do something like 1, 2, 3, and it uses this, I don't know the proper name for that, I call it the hat operator, and 2, 3, 4. So that's 2 arrays. Here we get an undefined method for array. So it's trying to call that method on an array, and it's coming back undefined. Whereas if we use our sets and do the same, we're going to get 4 and 1. So what that method is doing for us is it's finding the things, it's comparing the two sets together, finding the elements that are exclusive, so that aren't in both, and then joining them together into their own set. And that's pretty neat thing that we can do with sets. Sets are going to be faster for some things because of how they're structured. Caret, perfect. Yeah, I guess that works, caret, because I was thinking these were carets, but I guess those are greater than, less than, and that can be a caret. Right on. Sets are faster for some things, for iterations. I know that they are because I did some code test once, and when I iterated through an array, the website said, you know, this doesn't work fast enough. You have to make it faster. And I was like, okay. And I found sets, and I used a set, and it was a lot faster iterating through. Obviously, that's not going to be true all the time, but depending on what you're doing, it's good to know that there's other data structures out there like a set that you can try if you run into that at some point in time. So got sets. And last thing that I have on my list to look at, it looks like we have about 6 more minutes until question and answer time. If anybody has questions or answers, or I guess questions, is the range. I don't have much to look at with the range, so we should be able to get through this in 5-6 minutes. So the range class and data structure is a sort of quasi collection. And while it can be iterated through like other collections that use enumerable, it's not a container for arbitrary elements. So that's where it differentiates itself. So let's exit here and start a new IRB terminal. Actually, I want to clear this and then start a new IRB terminal. I'll throw some stuff in here. So let's say R equals range.new. Let's say A, comma, C. And then we can iterate through that with I, and say puts I, and see what we get. So let's do that here in our terminal, or I'll just speed up this one and copy it. So we see we get this A string dot dot C string, which is interesting. And then I'll call the iterator. We get ABC. So the range is going to be everything from the starting value to the ending value. So we're going to instantiate it with two arguments, as in this case, A and C, and it's going to include everything between A and C as well. So when we iterate through it, we get ABC. Now, we can also use ranges for slicing arrays and producing indices for iterating through them. So another example might be, let's say, letters equal, and this is going to be an array. And let's make them symbols, B, C, T, E. So that's created. We call letters, and we use a range. So we say 1 dash or dot dot 3.
Looks like Seth dropped out. There he is.
Yeah. I don't know what's going on with the internet right now, because I was on Zoom earlier, no problem. But this last thing, and then I'll let you go, and I will call AT&T in the morning and yell at them. Or figure out what's going on with my router. Cool. So the last thing that I was chatting about was using ranges in a case statement. They can be very useful to access some more cases that we might want to do things with. So something like case year, and we could do let's run the end on here. We could say when 1970 to 1979, then yeah. Maybe rule. Or when 1980 or when it's like 1980 to 1992, you get the picture. And disco. I don't know if that was disco or not. But that was what I had to go over this evening. Looked at arrays, hashes, sets, and ranges to look at a few different data structures in Ruby. There's a couple others that I found, matrices and vectors. I couldn't find any good examples, to be honest, so I'm not sure how often they get used. They seem like they're more complex math sort of logic in Ruby. Would be interesting to see what they do, but there also might be really deep down that rabbit hole, and I didn't want to go finding that out with things that really we're not trying to use right now. I think sets and ranges are very useful at this point in time, especially how sets, you can't create sets with duplicates, so that can be very useful depending on the use case for you or any of you at this point in time. So with that, any questions I can answer? I know we went through a lot, and I want to make sure that you're understanding these things as best you can. Okay, well, I'm not seeing anybody speaking up. So with that, I will say thank you very much for coming out this evening.